So you have checked your work on plotting these 5 stratovolcanoes. You'll notice one of them is an American stratovolcano, Mount St. Helens on the coast of near Washington, in Washington actually. And so the first question I had after plotting stratovolcanoes, though, asked you to look back at your shield volcanoes. So let's do that together. And so these are the shield volcanoes. Remember, number 3 here is Mauna Loa in Hawaii, and these are all volcanoes that behave like Mauna Loa. Our general statement about them, remember, was that they were generally on oceanic crust. If you said they're in the oceans, that's okay too, but oceanic crust is what's melting into the magma there. Now, when we look at our stratovolcanoes right here, though, notice the difference. This is what you just finished. We would not say that those are in the middle of the ocean. Instead, they're near the continents. And I also made a map where I put them on there together. So the red that you see are the shield volcanoes. The purples that you see are the stratovolcanoes. And so there's a big difference in their location. Now, there's a scientific explanation for this difference, and it has to do with the secret ingredient. Do you remember it? Silica in the magma. So what kind of crust, continental or oceanic, has high silicates? That would be our continental crust. Our oceanic crust is the opposite. It's full of native elements and non-silicates. So what is the connection between silica and the source of the magma? This is the one that students historically have struggled with a little bit. The reason that we get non-explosive eruptions at those shield volcanoes are because oceanic crust is low in silica. And the reason that you get explosive eruptions like Mount Fuji is the continental crust that gets mixed into the magma is high in silica. Remember that black stopper is like the silica. Silica in the magma is like peanut butter like magma. Pressure builds till boom. It's no coincidence where we have the shields versus the stratovolcanoes. It's all about, is it continental crust that's high in silica or oceanic crust that's melting into the magma that's low in silica?